Hi friends, welcome to the channel Learning R is Fun. In the last two videos we have covered ggplot2 basically to help us draw various charts layer by layer, and in this video we will be touching upon the date and time aspects, how date and time are represented by base R. In the next video we will be covering the LubriDate package to deal with the same subject. Now, handling date and time is not an easy affair. As you can see, we have certain complications. One is the leap year, the other one is certain days. Certain countries have DST, that is daylight saving time concept, and they move the clock backward or forward in certain specific days. So basically it becomes 23 hours or 25 hours per day. And again, to compensate the Earth's rotation gradually slowing down, seconds are added to a minute, and there are certain situations wherein a minute will have 61 seconds. So across the country, when times are to be referred and times are being measured, all these complications have to be kept in track. And R does it in its own fashion. All the countries in the world follow a standard which is known as Coordinated Universal Time, UTC, and they also follow a reference time, that is a time zone which is GMT, Greenwich Mean Time. Greenwich is a suburb of London, and the time at Greenwich is the Greenwich Mean Time. And UTC time and Greenwich Mean Time are one and the same. Only thing is Greenwich Mean Time is a time zone, whereas UTC is a time standard. And every 15 degree towards west is 1 hour earlier than GMT, and 15 degree longitude towards east is an hour later. The world is following various time zones, as you can see in the map, and operating system of a personal computer will maintain various time zones, and we can appropriately use the time zone and then work with it. This portable operating system interface, POSIX in short, POSIX is the class in which the date and times are maintained. It has got two subclasses, which is POSIX CT and POSIX LT. POSIX CT is basically calendar time, and POSIX LT is the local time. Here there is one difference. In POSIX CT, the date is internally maintained as the number of seconds that have elapsed since 1/1/1970. So it's a single value of seconds. What if the date is prior to 1/1/1970? Then that seconds are mentioned in negative number. In POSIX LT, various components such as seconds, minutes, and hours, etc., these are being combined in the form of a list. So POSIX LT maintains this date and time as a list, whereas POSIX CT maintains it as a number of seconds. That's the difference. And both have got its usefulness. However, we will be using POSIX CT more often, and we can see further. The various components in POSIX LT are shown in the slide, and because of the daylight saving time, how the clock is being moved is also seen. In base R, we have various functions to deal with the date and time. Systime will give you the current time, sysdate will give the current date, and we can have functions for converting to date objects and date objects to strings, and to find difference between two dates, we have got an object that is diff time. All these things will be very clear when we work with the R. So we go to RStudio and get on with the business. We will start the session by finding what is the time zone being followed in this particular PC. In your PC also you will get similar results. That is sys.timezone is the function. Okay, now what is the present time? That we can get using sys.time, and we will assign it to t. Let's execute this. In the environment we see t, and let's see what is it. it's a POSIX CT, that is calendar time. So this is generally what we use, and POSIX LT is only when you require specific components. Okay, now this is the object POSIX CT, but when you ask it to be printed, then you will see it is printing in a character string. So internally it is storing that as a POSIX CT object, and if you convert this object as numeric, then you get the number of seconds that have elapsed since 1/1/1970. We can verify that. What we'll do, this as numeric t will divide by 365 days into 24 hours into 60 minutes and 60 seconds. So the number of years we'll get, and that is about 50.8. That is 1970 plus 50 is 2020. So we understand this is being expressed in terms of seconds. So we'll convert the t, which is POSIX CT, into POSIX LT using as.POSIX LT. So we got it now, but that is available in the form of which is a list. You can see here it's a list. If you look at here, you get it's a list. But this list is something you cannot directly use list indexes and get things out of it, for which we have to do a special unlisting. Now what we'll do, we'll print and see, but printing is just characters only. Internally the POSIX LT is a POSIX LT object, whereas externally when you display, it is only a character string. So normally in names L, when you are asking the individual members in the list, their name should come, but it's not coming now. So what we'll do, we'll unclass it, then we'll save it in the LUC, that is the L unclassed, local time unclassed. Now we got this LUC as a list of 11. Previously it was list of 1 only, but here it's a list of 11. So once we have done the unclassing of the POSIX LT, we have got a simple list now. When the simple list is available, you can extract from that the first element. Let's say first element is seconds. If you want to know all the elements, then you can click here. Then you will see seconds, minutes, hours, day. These are the various elements, and various data types are there and various values are there. This is how POSIX LT is being stored. So you understood that. Now we'll move on. As.date is a function which is basically converting a string into a date. So when you make a string as a date, then it can be used as a date by R. Otherwise it will consider that as a string and continue to work with that as a string, which is not going to be useful. Now to convert this string into a date, we are using as.date function. We have to give a format also. That is how this date has been constructed within the string. It is by Y, that is only 2 digits of the year, the last 2 digits, and then month, that is M, and then day. And the separator is also shown here. With this, R will be able to find out what is this date and it will store that. So it has found out it is a date, and as usual, though it is a date object, but still while displaying it will display it as a string, and it has correctly displayed this as a 2020-10-16. While displaying it uses hyphen, even though the separator is / here. Now we'll slightly change the strings here. We'll make full length, that is 2020. Now we'll write the month name and then date. In this case, we have to give the format like this. For 4 digits of year, we have to give uppercase Y, and for month in abbreviation, we have to use lowercase b. Otherwise, the month is in full length, that is October. If it is written that way, then we have to use a uppercase b. For day, we will write only day. Now again, R will understand this and display it as usual. Okay. Here the separator is already hyphen, so here also we have to use the hyphen. But here the separator was /, so we have used the / here. Okay. Now we will convert again a string with the time also, that is 8 hours 5 minutes and 3 seconds, and this whole thing, that is date and time separated by a space, and here in the format we are having forward slash here, and here we are having a colon. Same thing is being done in the format. If you see percentage y, because 2 digits are there, m, d, and for hour, minute and second we have to use uppercase h, m and s. This is the formatting. Once we use the formatting, and we also give a time zone, that is UTC. Now as POSIX CT, I want to store this string. Okay. Once I make it, this is a now date time object. This object is now basically having all the characteristics, and it is, you can say, though it displayed as a string, it is POSIX CT object. Now let's use, so far we have done conversion of a string into date. Okay, we'll take the date and convert it into string. So the function is strf time, string format time. So again format is given, and t is what we have already got the object, and now that we will store in the timestamp. We'll put brackets so that display is straight away coming. So I got a timestamp here, which is shown as a string here, and if you look at this also, it is showing character string. So the string conversion takes place already from date to string. So we'll have one more example. In this case, we are not going to give hours and minutes and time, and the same t is now changed into timestamp using a lesser format. So here we got the time, here we don't have the time, because in the formatting we have not specified it. Okay. Now the reverse of this is this string p time. That is, here when we say p, what happens is the character we are converting into a date object. Previously we used as.date, now we are using a function. Otherwise we see the same thing. Format you have to give, you have to mention the time and date in strings, and then this conversion takes place, and earlier is now is the object where this is to be stored. So we have created an earlier object, and earlier object, if you see, it is a POSIX LT. So string p time converts this as a POSIX LT. Here we have done as.date, correct? And we will copy this and write here class, then we will paste this. We'll ask for it. So it's a date class, but here we have got a POSIX CT object, and now we are using a different functions. Strip time, when you are using a strip time, you got earlier. The earlier what you got is a POSIX LT class, and we can ask also here a class of earlier. It is showing it's a POSIX LT and POSIX T. So that's the difference. Otherwise you are getting the date object in both the cases. Okay, we'll move on. We made earlier. Okay, since it is an LT object, you can get the first element. So earlier, when you say with index, you get it, or when you unlist it, you get a better information. Like we got, it's a minute. Similarly, we'll make a later, again using a strip time, and between earlier and later, if you see, the difference is just 1 hour. This is the hour and minutes and seconds. The date I have kept the same, only the hour I have changed. So I will convert the string into date time. Now we have got earlier and later, two different times. There is a diff time object. We can use a diff time function in which we will say later and earlier. So the difference is going to be computed, and that will be as a given as a diff time object. Let's see this. It's a time difference of 1 hour. This is basically the result. And help diff time, if you ask in the pane, help pane, you will see the time intervals creation, printing and some arithmetic. Basically it is giving the difference of time 1 and time 2. And further examples are given, and there is a description. Function difftime calculates the difference of two datetime objects and returns an object of class difftime. That's what I said. So we got an object when you do this. Now this object when you can display using units as seconds. So if you do that, time difference of 3600 seconds. Instead of 1 hour, we are now getting it in seconds. Now this diff can be used intelligently, like we got system plus 48 days later. What will be the date and time? Suppose I am asking. Then you see, first you have to say 48 days and units is days, and that you have to convert as diff time. So the diff will be the object. In this object, you are getting the diff time value. So this is a diff time object. So the diff time object, when you add to the sys.time, you get the results. So let me execute this statement, then execute next statement. So now a diff object has been created and a diff time object, and that object when you are adding, what happens is 48 days is added to the existing date. The same time after 48 days is what is coming up here. So when you want to add a particular number of days or minutes or seconds to the present time, you can do that. If you make this as a diff time object, then that object will take care of it. Suppose you are writing simply some number, then also will be done, but that number will be treated as seconds. So you can see that by simply giving some seconds here, and then say for example I have given here sys.date plus 42. So what I will get 42 days from sysdate, whereas here it's a time. Therefore if you write sys.time, let me find out what is sys.time now. I'll enter, then I will write the same code plus 60 seconds. I will say already some time has elapsed. See, it's 05, 65 means it should have been 5, but 12 seconds have elapsed, therefore you got this. So basically what is happening is, when you simply add a number, that number to system, it is considering this as a seconds. But if you are adding a diff object, then depending on the object you get the change in time. Okay, now we'll move on. This is how to create a sequence of days. First you create a date from where the sequence should start. This is a from date, and then put it in a string, and then generally this is to be put in the year, month and day in this format. Then you convert it to date. So basically this will become a date. Using as.date function, we have converted this string into a date. So in sequence, the first object is normally a number, and then by you give and length you give. Instead of the number, I have given a date object now. And by how you want to make the sequence? By days I want to make the sequence. Length is 10. So now you see what happens. I got a sequence of 10 dates. Now sequence, the same thing I have given. Sys.date I have taken, and I have taken days and length. So that is from today's date. So I will ask what is my dates. It's going to be from today. I got the sequence here. You can see here 27, 28, 29, 30, etc. This we have already seen. Now suppose I want to know how many days I have lived. So sys.date minus my birth date. Birth date I have to give as.date. So I will get the number of days I have lived. Diff time. Now here what I am going to do, sysdate, that is the first element. The second time element is again this, which is to be converted as date. So you have got two dates here, and I am saying units is week. So what happens is this minus this you will get in weeks, and that will be your diff time object. You see, time difference of 25.85714 weeks. It is now time for us to wind up. In today's session, we have covered a lot of ground. We understood how R internally stores them, externally how it displays them as strings, and how to convert strings into date and date back into strings, and then how to find the difference of dates, and what is a diff time object, etc. We'll see actual examples of data sets and then how we can work on that, and then what are the better functions available in LubriDate package when compared to base R in the next session. So thanks for watching and see you in the next video.